Let's talk a little bit about maintaining the performance of your networks. I'm sure that's pretty central.
As we grow and as we are looking into how we are virtualizing all our environment, the day-to-day activities start to be very complex, especially right now that we are really putting all the efforts to be very virtualized, not only from the IT, not only from the core, but also from the radio side, from the wireless side. We are looking the future step for Afghan Wireless to see how we are going to step into the complete cloud era, cloudifying everything from end to end. So yes, it is very difficult because right now it's not only to sit down and monitor the KPIs or the benchmark, you need to be very proactive. The reactivity of the day-to-day job, which we call it the very classic way of monitoring a network, start to be very, outdated. Right now, if you are not proactive in what you are doing, you will be sitting on a chair, just troubleshooting on a day-to-day without knowing exactly where to look for, what to do, and how do you want to solve your problem. So the proactivity, or to simulate what could happen on your network, is more effective and is more crucial than just monitoring the network and looking to the KPIs. This is not only for Afghan Wireless. I do believe that this is also part of the day-to-day job for all these advanced operator or advanced platforms or virtual platforms.
So Abdullah, you talked about simulation and simulators. Could you expand on that? Are you talking about having a digital twin of your network, or are you talking about simple emulators of different parts of your network? So some more detail on exactly what you mean by the use of the word simulations and simulators.
Yeah, well, actually, we are not that mature to consider Afghan Wireless as like fully cloudified, because we are taking steps after step and we are taking different actions, but the final goal is to be cloudified. So when we talk about being proactive, the simulation and the proactivity is to try to predict what could happen, especially on a virtualized machine or the virtual environment. Especially when we talk about geographically, you have a different virtual services sitting on a different geographical locations. You need to simulate all what could happen, the connectivities, the end-to-end connectivities, the international connectivities, the cloud itself connectivities, the database connectivities, the recording. So this kind of a simulation is part of the day-to-day job, is to try to understand if this could happen or this will happen on any of the connectivities from point A to point B, what could be the result and how we can recover this. I can give you a live example. We are in a process right now to migrate on a complete cloud BSS, and geographically you need to think about a PR and a DR. And when you talk about geographical splitting the PR from a DR, you need to synchronize at a millisecond. We cannot afford to synchronize in a second. It's a millisecond synchronization. And the prediction about interruption of a service, if you lose your PR, if your synchronization is not at a millisecond, your DR cannot function on spot. So this simulation of interruption of services will predict for you if things will happen and your PR is down, how you can shift to your DR and continue seamlessly your connectivities and your services, especially on a BSS cloud system.